So my name is Asko. I'm my colleague Jukka Ojaniemi, and we are telling you about Plone and RabbitMQ. So this is about doing asynchronous tasks and queuing messages on Plone. Is there anyone there who has not ever integrated an external system with Plone? Or if there were, I think you... Have you ever, is there anyone here who has not ever integrated an external system with Plone? Okay, I'm sure you would love it after this presentation.
Okay, hello everyone. Do you hear me? Yes. Okay, so we are from University of Jyväskylä, Finland. This university is the biggest Plone user in Finland. We have about 83 Plone sites, 2.5 terabytes of data available through Plone, and 700 content editors, and only 7-person team who is managing all this, administering. Today we are going to talk about messaging, and by messaging we mean message queues. So we talk about in the context of message queues. We don't mean anything about instant messaging or like email, SMS.
Okay, but let's start with the demo. So if you can open that address that's reached here, and I hope my small server will handle the load, you will see something that, okay, it looks like a chat application, real-time one, but actually it's a demonstration of how we can queue write operation on ZODP. Because as we well know, ZODP is not very good with concurrent write operations. Sooner or later you will end up with a lot of conflict errors. But what happens in this demo, if we can make it work, whenever you add a message on the demo and presenter, the message will be sent to the message broker, RabbitMQ in this case, and will be queued to site-specific message queue. And Plone will continuously, asynchronously, on background, consume that message queue, and then one message by time, consume those messages and store them on the ZODP. And this will be handled by one single-threaded TO client, not the one you will see on your browser. So that's what's happened there. And now Jukka will tell us more about RabbitMQ and what's on the background with AMQP.
Okay, thank you. So why message queues? We have several systems which communicate with each other, and it depends on the developer who has migrated or done the communication stuff, how those are connected to each other. So we have stuff like XML RPC requests or messaging, maybe HTTP requests like post or get, or then we had just like database dump, and those files were transferred like via SCP. So the the environment was total mess. But we need reliable and effective and scalable solution for system integration, and well, the message queues were the one we were really looking for after.
So what were our options? We were looking, of course, Plone app async, but that was foreign for us. And from the internet, we heard that it may be not the best solution to use ZODP for store message queues like stuff. Also, it wouldn't be so easy to integrate with other systems. With external broker, you can easily, it's independent from your Plone or job system. Also, of course, there is XMPP stuff going on with Plone, but that looked like more real-time and more complex real-time collaboration solution, and a little too complex for us. So, as we read from the quote from Andres Zhang, we took the known, good, real working solution. So external message broker, RabbitMQ with AMQP.
So what is AMQP? You can think of it like it's a post office. So if you want to mail something, you write a letter and drop it in the post box, and you forget it. And then maybe someone answers you, so you check your own post box, and you have a mail, and you read it. And you don't care what happens in the between those steps. So AMQP can be a bit more than regular post office, but you still have. What you need to know is that you have the address field and the message, and the magic happens in the AMQP protocol. Here we have some AMQP jargon. So what are the building blocks of AMQP? So you'll use producers, exchange, bindings, queues, consumers, and of course the message itself. And the message consists of label and payload. And the label is basically the address, and the payload is the actual message data. And the data can be anything you can imagine. Producer is a program which sends the message to the AMQP broker, and consumer is a program which mostly waits to receive the messages. Then we have the message broker, and in the broker there is exchanges, bindings, and queues. When the producer sends a message, it goes to the exchange, which passes it to the queue. And bindings are how the message gets routed to the exchange and to the queue. Queue is basically an infinite buffer which stores the messages. And when the message arrives to the queue, it will be sent to the consumer, which has subscribed to the queue. And here we have a basic messaging methods, how the AMQP can be used to. And the first one is work use, and this is ideal for asynchronous tasks or system integration. And here we have the message in the producer, and next step it goes to the exchange, and now we have next message in the producer. And those messages go to the broker, and it distributes those messages to the consumers. Next example is publish subscribe queues. So here we are using fan-out exchange, and basically message goes to the exchange, and then the fan-out exchange distributes it to several queues, and from the queues same message goes to the several consumers. The idea behind the fan-out queue is that if you have, say you have some program and you need to integrate it to some other program, you could do it with the direct exchange, but then someone says you that we have the third program and you need to integrate also to that. So you should change, with the direct exchange, you should change the code so that you have the producer end and the consumer end changes, so that every new requirement needs changes to both sides. But with fan-out exchange, you only change the consumer side. And sometimes we need to implement RPC-like behavior with messaging, and with AMQP this is quite easy. Here, the producer needs to add a bit more information to the message it is sending. Basically, it needs the replicate queue and correlation ID, which is basically ID for the message. And when the message goes through the broker, it goes to the about the same ways like with direct exchange. It goes to the server, and the server does some stuff with it, and then it returns the message to the message queue. And it uses the replicate queue and the correlation ID to route the message. So it goes back to the publisher, and now it knows it has done everything it needs. We are using RabbitMQ as our AMQP server. It is probably the most widely used broker which fully implements the AMQP open standard. It is written in Erlang, which is language designed for building massively scalable soft real-time systems with requirements of high availability. RabbitMQ is also open source project, and it's widely beta tested by Mozilla, Google, AT&T, and similar. So, does this sound complicated? Maybe. Pascal?
So I must claim that it's actually quite easy. So how to make a Plone site to talk AMQP to the RabbitMQ broker? So we started about not a year ago, a little less, last spring. We started Affinity AMQP product that was released by a company named Affinity. And well, one thing led to another, and we eventually almost completely rewrote it. And now we have rebranded it as collective.zamqp, and we hope to drop it onto collective GitHub repository soon. It's already available at GitHub and also on PyPy, but it's still on my private or on my personal repositories in GitHub. So, well, even if we almost rewrote it, we still kind of preserved the way it worked, and I like the way it worked. So let's see how it works. With a simple example of publish and subscribe. In this example, we publish and subscribe announcement. We have one Plone site who wants to publish something. For example, announcement messages. There is maybe a custom form you fill, and then the message goes to broker. And then we have a few more sites who want to consume that message and maybe somehow publish to the visitors. So for site R, we must have. For site A, we must have. We must define a utility for producing messages, but once we have done that, we only call that utility and maybe register it for transaction, and then publish the message. And actually, that is enough to send the message to broker, and then according to the configuration made when we define the utility, the message is routed to the consuming queues. And for the sites B and C, who are consuming the messages, we configure another utilities we call consumer utilities. And once we have defined those, we only need to, well, those utilities will stamp the messages with the marker interface we have defined, and then we only need to subscribe those events with that marker interface. And we subscribe them like any object event in Job in Plone, and do anything we want, and in a regular request-like environment. And then at the end we act the message. And messages are automatically registered for transaction. So if something happens some error happens during the processing of the message, it won't be acknowledged, and it will stay on the broker until we have fixed the error. So these are the base things, but of course there are a little bit more to make the whole thing works. So at the very end we must define broker connections. We do those by defining them in buildout to make them part of the job conf. With the default settings, the only required parameter is the connection ID that must be unique for the connections. But once we make those connections, thanks to the library we are using, it's called Pika. It comes with an asynchronous connection utility that, well, I don't know how many nodes, but deep under the job, under Plone in job 2, the HTTP server on job runs on using async core called lib with Medusa server, and that's async core HTTP server. And what happens here, the AMQP connections of Pika library actually co-opts that asynchronous loop, so it will run next to the HTTP server of SOAP, and that makes it run pretty nicely next to SOAP. So we have connections, and once we have defined connections, we must of course define the producers. And producers are always tied to the connections, and then there are a lot of routing parameters. And well, I'm still in process of documenting those parameters. They have some nice defaults to make it possible to enter as little parameters as needed. But those will do the routing when we query the utility and send the message. And once we have sent the messages, the next core point. Oh, yeah. On the other hand, we have to define consuming servers. So they are very much like a SOAP clock server thing. We define them again in buildout, and they will end up the SOAPconf, and then also start asynchronous loop co-opting server that will receive the messages from the connection and then send them through the consumers you have registered and stamp the messages and then publish them to all our consuming handlers who handle the messages. And consumer utilities are much like producing utilities. They have lots of almost the same parameters. They have a little different defaults, but again, they are quite easy to define. And we have some examples at the end on the GitHub also, what we have done and how you can use this. And finally, when you have defined connections, producers at the sending end, and on the receiving end, the consuming servers, also they need the connections, consumers, then we can, in our code, register these event handlers to get the events, the messages, process them, and then acknowledge them. And I think that's about it. So there are a lot of new concepts to learn. First, the AMQP concepts and our implementation in collective.zamqp, those terms. But eventually, it won't need a lot of code to make this all happen. And what we think is great in this is that we haven't invented a lot of new things. We try to rely on the old established things like, yes, we use the SOAP through server approach. Our AMQP connections and consuming servers run next to the HTTP server, and then the messages are sent as HTTP request-like request in the same way like the SOAP clock server works, so that the messages will be handled in very familiar environment within a transaction automatically. So actually, SOAP publisher will handle a lot of things there for us in free.
Okay, so Asko has made a nice demo of this whole thing, and maybe we have still some time, so maybe we can check it out. You can also check it out. So it's not this one. Okay, there we are. So this is a regular Plone site with our add-on. And basically, it's a dexterity behavior. And, well, you can see how it works. And the URL on the top of the screen is working, so you can try it out right now. If you have questions, you can type it out there, and we try to answer. So as you can see, it's really fast, and it is writing to the ZODP all the time. All the messages are persistent. And as you can see, the green ones are still they are like submitted to the users, but not still written in the database. And when they turn out black, they are also in the ZODB. So, do you have any questions in mind? There's one.
You know, when you began to start using RabbitMQ and MQ factory, you search about salary library, Python library?
Yes, I look into Celery, and you can make this work with Celery. But I think Celery was too opinionated for us. So, of course, it is made for work with very different message networks. Also, not only AMQP. So that's why you really need to know how Celery works to work with it without Celery, and use this very specific message format with it. And so we wanted to and needed to make use of the RabbitMQ and AMQP features, all of them. And so we really needed to get the Celery out of the way eventually. Any other questions?
Is the example code available online?
Yes, can Jukka find the final slide? So please don't do a message or chat application on base of that, but please see the XMPP presentation later. But there are also a few other examples on other repository. Can you, Jukka, show the last slide that shows all the links? Okay, so here are all the relevant links.
How easy it is to install RabbitMQ?
You can install RabbitMQ in buildout. There is a recipe for that, and the recipe will install the RabbitMQ from source. And you can also add another part into GitHub into buildout to also compile the Erlang language for the RabbitMQ. So you can compile both of those in buildout. And when you use the recipe for compiling it, it will install everything under the buildout directory. So you won't need system-wide installation. But you can also use system-wide installation. Also, I've tried this with Travis CI, and there it was more easiest way to install the system-wide Erlang, and then use the build-out to install RabbitMQ. And all these collective ZAMQP demos repository and chat behavior repository contain complete build-outs for compiling all the necessary stuff. Of course, they will have, I think, not optimal configure options for Erlang to make the Erlang compile on most of the platforms. So they may not be production quality.
Okay, we still have a few minutes, so I'll still say a few words about this in production. So we have used this for video publishing site at our university. We recently refactored it. It used XMRPC communication, and it was really horrible. There were some bugs, and we weren't quite sure if it was because of the network, hardware, or the software. And debugging it was a nightmare. So we needed like more reliable solution, and we ended up with this. This slide probably won't work, but it shows the communication in our system. But currently it uses RabbitMQ, and everything works perfectly. You can always know where the messages go and what it should be doing. And it is directing 48 encoders, so there will be a lot of traffic, and it's under heavy load.
So it's about time, so thank you for one more question, okay?
subscribers and one queue, how do you know which subscriber gets the message? How do you
Well, the design behavior is that the broker will deliver the messages in round-robin way. So one message will be sent only for one consumer in direct exchange. If you use fan-out exchange, then every consumer will have their own queue, and so they will get their own message. Okay, thank you.